Okay, welcome folks. This is Foundations and Pre-Calculus Math 10 with Mr. Johns. We are doing the last section of Chapter 5, which is interpreting graphs of linear functions. And so we are going to use intercepts, rate of change, domain and range to describe the graph of a linear function. Any graph of a line that is not vertical represents a function. So it's got to pass the vertical line test. We call these functions linear functions if they're straight line. We can use the intercepts to describe the graph of a linear function. So if we have a straight line that continues, at some point it's going to hit the y-axis, and at some point it's going to hit the x-axis. This is the x-intercept, this is the y-intercept. So this graph intersects the horizontal axis at x is 2, where y is 0, and it intersects the vertical axis at x is 0, y is 5. So the coordinates are 0 and 5 here, and 2 and 0 there. So now we're going to find intercepts, domain, and range of a graph. I'll let you go through that example, and I'll do this one with you. So this graph shows a person's distance from the finish line for a bicycle race. So they started at 100 kilometers away and ended at 0 kilometers away from the finish line. So they finished the race. Find the vertical and horizontal intercepts. What do they represent? So the graph intersects the vertical axis right here, and that is the value 100. So the vertical intercept is 100. This represents the distance from the finish line. At the start of the race, at 0 hours, they were 100 kilometers away. The graph intersects the horizontal axis at this point. So 1, 2, 3, 4, and that would be 5. So the horizontal intercept is 5. This represents the time when the distance from the finish line is 0 kilometers after 5 hours. You try this one. Or I'll try this one with you, sorry. Find the domain and range. So basically the domain is where it covers on the horizontal axis, and the range is where it covers on the vertical axis. So on the horizontal axis, the shadow starts at, so basically we're going to cover this part. The shadow starts at 0 and ends at 5. So the domain is 0 is less than or equal to t, which is less than or equal to 5. On the vertical axis, the shadow starts at, again, 0 and ends at 100. So the range is 0 is less than or equal to d, which is less than or equal to 100. Now, looking at the graph is one way to find the intercepts and the domain and range, but another way to do it would be to use the actual function. So we can plug in values to find the x-intercept, we'd use y is 0, and to find the y-intercept, we would use x is 0, and then we can algebraically solve for these intercepts. So, we can use intercepts to graph a linear function as well. To find the y-intercept, substitute x is 0. To find the x-intercept, substitute y is 0 into the function. I'll let you go through this example, which is sketching a graph using intercepts, and I'll do this one with you. So, let's use the intercepts to sketch the linear function y equals negative 2x plus 6. So first we're going to find the y-intercept by using x is 0. So I put in a 0 for my x in brackets. Negative 2 times 0 is 0, plus 6 is 6. So the y-intercept is at 6. And remember, as a point, this is 0, 6. To find the x-intercept, substitute y equals 0. Now this is a little trickier because I have 0 on my left side. Then what I'm going to do is subtract 6 from both sides to put x all by itself. And I have negative 6 equals negative 2x, because 6 minus 6 is 0. And now I'm going to divide both sides by -2, giving me 3 equals x, or x equals 3. Now remember, this point is 3, 0. So here we subtracted 6 from both sides and divided both sides by -2. So to graph this, basically I need the point 0 and 6. 0, 4, 6 is the y-intercept. And then 3 and 0. So 3 and 0 here. And if we want to find the coordinates of another point, we could use, say, x is equal to 1. -2 times 1 is -2, plus 6 is 4. So this point has the coordinates 1 and 4, which is 1 over, 4 up. Mark points at 6 on the y-axis, 3 on the x-axis, and at 1 and 4. And then now, we really only need 2 points, but with 3 points we can be sure. We draw a line through our 3 points. And then I like to label this line with the function y equals -2x plus 6, because that's the equation for this line. Okay, example 3. Matching a graph to a given rate of change and vertical intercept. I'll let you go through this example if you need. And I'll go through this example. Which graph has a rate of change of 1 and a vertical intercept of 9? So, first off, this number is positive, so the graph is increasing. I can tell the rate of change is going up quite evenly, so they're both a possibility. But the vertical intercept being 9, this goes up by 3, so this one works. This could be 9. And this one goes up by 9s as well. So both graphs have a vertical intercept of 9. For each graph, the rate of change is the change in the dependent variable, which is distance, over the change in time. So let's figure out the rate of change. In this case, we need 2 points. So I will say 27 minus 18 over 6 minus 3. And this will give me 9 over 3, which is 3. So the rate of change is 3. In this case, I will use these 2 points, and it'll be 15 minus 12 over 6 minus 3. 15 minus 12 is 3, 6 minus 3 is 3, and 3 over 3 is 1, so the rate of change is 1. So it asked me which graph had a rate of change of 1. Well, it has to be this one, because this one had a rate of change of 3. Even though they look similar, this one, the distance scale was different. So this is the correct graph, and this is not. So graph B has a rate of change of 1 and a vertical intercept of 9. All right, we've done all we need to do to learn Chapter 5, and now we'll finish this assignment. I would like you to do number 1, number 2, number 3, number 4, and number 5, which is the whole assignment. After you're done section 5.7, we'll be doing the chapter review. So I've included a study guide here, and basically I would like you to do from 1 all the way, every question, to the end of number 12. Once we've completed that, then we'll write the chapter 5 exam. Good luck. Let me know if you need help.